Well, welcome back and Happy New Year. Welcome to the year 2013. Hope it turns out to be an excellent rest of your senior year here. So let's try to get back in the calculus groove here, and I've got a nice AP type question for you. And today's topic, you can write down at the top of your notes there, is interpreting the graph of the velocity function. So let's go ahead and make sure we read the situation before we dive in. Jenny rides her bicycle from her home to Lauren's home, starting at t equals 0 minutes and arriving at Lauren's home at t equals 15 during the time interval 0 to 15. Her velocity is in miles per minute, so let's make sure we've got that units underlined. And then it's represented by this piecewise linear function whose graph is below. And I think it's really important that you label that graph v of t, and you keep in mind you are staring at velocity the entire time. So another thing to jot down is every time we think velocity, you should be thinking direction. This is telling you whether you are moving to the right or left. Okay, we've talked about velocity quite a bit by now. The other thing just to be real careful about are the units here. Clearly the x-axis is counting by ones, but just watch that y-axis. It's actually counting by 0.1, so be real careful there. Part A. After leaving home, Jenny realizes she dropped her calculus homework, and she returns to get it. At what time does she turn around to get her work? Give a reason for your answer. So if we just take a look at our graph, hopefully you're saying again, this is velocity. We've marked it off to the side, so I'm talking about direction. So from 0 to 4 here, this part of the graph represents Jenny riding her bike to the right. Then she comes to a rest. Of course, that's when velocity equals 0. This portion represents her riding her bike to the left. Then she comes to a rest. And the rest of her direction here is riding to the right. So hopefully you can interpret that on your own by now. So what time do you think she dropped her calculus homework? Well, hopefully you've said by now that happened at t equals 4. So again, she was riding to the right, came to rest, because v of t is equal to 0. So we can note that she came to rest there. And now from 4 to 7, we know that she is now riding to the left. So she has turned around. And our justification there is our v of t is less than 0, or is negative. All right, part B. Find the acceleration, if it exists, of Jenny's bike at t equals 4, 10, and 12. If it does not exist, explain why, indicate units of measure. So let's recall, we are staring at velocity, and I believe they told us our units were miles per minute. Okay, so now my goal is to go get acceleration, and that's the key trigger word there. So all you have to do is, again, say to yourself, I'm staring at velocity. That's why it was so important to get that down. And if you want acceleration from velocity, you should be taking the derivative. So basically, I need to look at v prime of 4, v prime of 10, and v prime of 12. I'm looking at the slopes of each of these. So simple enough. Let me start with 4. If I go to 4 and I want the slope, notice I'm not saying where is it sitting, I want the slope. Basically, I just want the slope of this line here. And I can simply count rise over run, starting from this point to this point. So I would say that's negative rise 1, 2, 3, 4 over 2, or negative 2. Now hopefully you'll notice I already made a quick little mistake here and hopefully caught myself. My rise isn't actually 4. My rise should actually be negative, let me change colors here, negative 0.4 divided by 2, so I should get negative 0.2. And because I'm taking the slope, that should be miles per minute squared. Okay, so again, be real careful that we are counting by 0.2s here like I had already missed. V prime of 10. So now I'm going to do the same thing, and I want the slope here at 10. All right, now hopefully you've already jumped in your head an answer of does not exist. And again, we had a corner or a cusp there, but we like to call that one a corner. Now, you can't just say because there's a corner. And we've talked about this definition before. We need to use that limit definition. The limit as t approaches 10 from the left of v prime of t does not equal the limit as t approaches 10 from the right of v prime of t. And notice, I am definitely saying the slopes are not equal. That's what I'm saying by v prime. I am saying the slope on the left does not equal the slope on the right. And that is why the definition does not exist here. And lastly, v prime of 12, and that's a pretty nice one just to look at. I need the slope of that line. That dot happens to appear on this line here, and of course that just has a slope of 0. And again, watch those units. I'm talking about acceleration, so that's miles per minute squared. Miles per minute squared. All right, so this is very similar to an AP question. They've given us A and B, are pretty straightforward, and now they throw a twist at us. Suppose Joseph starts riding his skateboard from home to Lauren's home at time t equals 0, arriving at Lauren's home at t equals 16. During the time interval 0 to 16, his velocity is in miles per minute, so let's underline that, and it's modeled by this function. So notice they're not giving you a graph this time, they're giving you a function instead. So question C, who traveled farther, Joseph or Jenny? So think about what you're trying to compare. If you want to know who traveled the farthest, you would want to compare the total distance traveled by both Jenny and Joseph. All right, so let's start with Jenny. Stop, Bailey. Whoops. Okay, so Jenny, I'm going to calculate her area from 0 to 15, and remember, total distance traveled is the absolute value of velocity. Okay, so watch that integral setup. Remember, we want setup and an answer. Total distance, we've got to use the absolute value, and make sure you have a nice dt on the end here from 0 to 15. Okay, so I need to go get everybody's area real quickly. So in this section, I've got 4 times 0.2, that's 0.8, and half of that should be 0.4. This section, I've got 3 by 2, which is 6. Well, half of that's 0.3, and I'm below, so make sure you have that negative. I don't like the trapezoid. I like to go triangles and rectangle or square if I can. So I've got, what is that, 0.9, 0.3, and what's that look like, 0.45. Hopefully you can check my math and I'm good there. So if I want total distance traveled for Jenny, I'm taking the absolute value of all these areas. So I'm going to say that integral is equal to 0.4 minus 0.3 plus 0.45 plus 0.9 plus 0.3. And remember, I want to take this guy's absolute value, so I'm actually making it a positive value. And if I add those together, I think that gets me 2.35. And I integrated, this was miles per minute, so that's going to get me 2.35 miles. And again, that is the total distance traveled by Jenny. And be careful, we did take that absolute value here. Okay, make sure you made that positive for total distance traveled. Now, we need to do the same thing for Joseph. Recall, though, we're not going to look at the graph this time. We're going to use that function they gave us. So, and it said it took him 16 minutes. So from 0 to 16, absolute value of v of t dt. And we knew his velocity, they told us, was 1/16 radical t dt. Okay, so I'm going to pull out, the absolute value isn't going to affect this too much because this function's already positive. I already know that the square root of t looks like this, so I don't really need to worry about the absolute value. I'm going to pull out that 1/16 and just integrate t to the 1/2 from 0 to 16. Now I don't need any fancy u sub, this is just a straight integral. So that's 3/2 times 2/3. Oh, if I keep going here, that's an 1/8, that's 1/24. T to the 3/2 from 0 to 16. Sixteen to the 3/2 minus 0 to the 3/2, that's nothing. The square root of 16 is 4, 4 cubed, 64. Times my 1/24, looks like a total of 8/3 or 2 2/3 miles. So just be sure you actually answer the question. I would say Joseph traveled farther than Jenny. Okay, so now I'll change the question just slightly. Who lives farther from Lauren's home? And show the work that leads to your answer. So I don't necessarily want total distance, I just want to know who lives the farthest. So I still want to find the change in position. Or I could say to myself, I want my answer to be in miles. So to get that, I would simply just integrate. So let's start with Jenny. I would just integrate from 0 to 15 v of t dt. Notice I'm not saying total distance traveled, so I don't want that absolute value. So this time, it's like finding the net change or displacement. I'm just going to take the 0.4, and I'm literally going to subtract the 0.3 this time, plus the 0.45, plus the 0.9, plus the 0.3. And again, that will get me the net change for a total of 1.75 miles. Okay, so hopefully you've caught on now between the difference between total distance traveled when you take the absolute value versus the net change. And again, that net change is accounting, let me scroll back here, is accounting for this section here. It's taking this value and subtracting this one because she turned around. She's not traveling, that distance to get to her house. So we subtracted those two out for the net change versus the total distance. And now Joseph, we'll compare him. I'm still going to integrate from 0 to 16 of v of t dt, which in fact isn't going to change our answer at all, so we're still going to get 2 2/3 miles. So in this case, Jenny actually lives closest. Even though she traveled further in the first section, she actually lives closest. Whoops, I might have just said that incorrectly. Joseph traveled further in that previous section, but Jenny lives the closest. Okay, well that does it for our first video back to school here in 2013. It was a little rough on my part, and hopefully these will get a little better here. We look forward to seeing you tomorrow. Have a great night.